Okay, so in this example, we're going to try and sketch a graph of each function. We're going to do that by using the information that we found in the examples. Now, these are the same 3 examples that we used in the first part of this lesson. So I'm going to go back to that slide where we collected all that information and see what information I can bring back into here to help me sketch this graph. So if I go back to the slide, this wonderful slide that we had here that gave us all the information. Let's just look down at this very first thing. We found out that in the first derivative, we have the first derivative is equal to 0 at 2 and -1, which gave us a maximum at -1, 7, and a minimum at 2, -20. So let's go ahead and put that information back onto that slide and use it for graphing. Okay, so we know we have, oops, wrong thing. So we know we have this minimum. Oh my goodness gracious, why keep grabbing the wrong things here? We know we have this minimum and this maximum here. Let's just get that out of the way. We have this minimum and this maximum. Okay, we also know from that slide that we have a point of inflection. We found down here that we had a point of inflection at 1/2 and -13/2. So let's go back and write that in. So we have a point of inflection at 1/2 -13/2. Okay, and what we also found out from the second derivative was that we were concave down from -infinity to 1/2 and concave up from 1/2 on. So we're going to write that information down. So you can see how all of that information is going to be used to help us graph. So it was, what was it? It was down from -infinity to 1/2, and it was up from 1/2 to infinity. Okay, so using all that information, I'm going to try and graph this thing. The other thing I wanted to do is I have the ability to find the x-intercepts. Now, that's all stuff that we did in Algebra 1, basically. So I'm going to go ahead and find the x-intercepts by factoring. So this is actually equal to, you know what? I'm going to type this in my calculator and use my polynomial tools to factor it. If you wanted to, if it was a calculator question, we could do that. If it was a non-calculator question, what they would do is they would judge us on the approximation of the x-intercepts on the graph. Okay, but I know from my polynomial tools that my x-intercepts are 1.81 and 3.31. So hopefully they'll fall within there when we just make these points here. All right, so my maximum is at -1, 7. So let's make that -1. Yeah, we're going to make each one of these thicker lines 1, but we'll count the thin lines on the y-axis as 1. So this is -1, 7, 5, 6, 7. So we know this is a maximum point right here. We know there's a minimum point at +2 and -20. So that's way down here. We're going to approximate where that goes. We know there's a point of inflection at 1/2. So it's right about there. And -13/2. That's at like 6.5, right? So we're going to approximate. Now, like I said, IB grades on approximately the shape and the x-intercepts and the minimum in the right place and the maximum in the right place and the fact that it's going down when it's supposed to and up when it's supposed to. Okay, so we know that from the -infinity to 1/2, it's concave down. So that means this thing is going to be like this, okay? And we know from +infinity to 1/2, it's concave up, so it's going to be like that. So you can see that if we extend these pieces, this 1/2 falls into my point of inflection, and it doesn't actually on this graph just because I didn't go down to -20, but it's about where it would be. Okay, so this is the approximate graph from the information we were given. All right, for letter B, if we go back and we look at what information we found out, what we were able to find out from the first derivative was that we had a minimum at 0, 4. So let's go ahead and write that information down. So we know we have a minimum at 0, 4. Okay, let's go back and see what else we found out. Second derivative told us that there was no point of inflection, basically. Okay, but what we do know, that because it's a rational function, is that it has asymptotes. If you remember, we put these open circles at the asymptotes. So it has asymptotes at x equals -1 and x equals 1. So let's go ahead and write those down, because that's going to be important. So we have, those are vertical asymptotes at x equals -1 and x equals 1. And we can also figure out the horizontal asymptote. Because the degree of the numerator matches the degree of the denominator, we use the leading coefficients. So that means it has a horizontal asymptote at y equals 1. Okay, and we also want to know where this thing is going, ups, downs, all of those things. So we got that from the second derivative. So we know it's concave down up to -1. It's concave up in between, and it's concave down after. Okay, so I'm actually going to recopy. I don't know if I can actually do this or if it's going to grab too much, but let's see what it grabs. That's too much. Okay, so I'm going to just write it in then. So it is going to be down when from -infinity to -1 and from 1 to infinity. And it is up from -1 to 1. All right, so let me put my asymptotes in first. That usually helps me out. So I know I have one at 1, so that's going to go across there. And I have at -1, so that's going to come down here. And I have another vertical at +1. I've split this graph paper into 6 sections, so I have to figure out what's going on here. So I have a minimum at 0, 4. So let's put our minimum at 0, 4. 4 is right there, yes. Okay, so, and I know in between -1 and 1, it's actually concave up. So that means it's going to look like that. Okay, let's look at the area below. It doesn't have maximum or minimum here, but it is concave down. So that means that it will approach that asymptote and it will approach that asymptote. And this one is also concave down, so it will approach this asymptote and it will approach that asymptote. So that's the graph of that one there. Now looking at x cubed is going to have an x-intercept, which we can find real quick. It is equal to 0. The original is equal to 0 when x equals 0. So we have an x-intercept at 0, and if I substitute that back in, 0 cubed is 0. So it has an x-intercept at 0, 0. Let's go back and figure out the other information we found out. We found out through the first derivative that it is no sign change. So there's no maximum or minimum. No maximum or minimum. Okay, what we did, however, find out is that we have a point of inflection at 0, 0, and it's concave down at the beginning of the graph and concave up at the end of the graph. Okay, so we can work with that. So what does that look like? So no max or min, inflection. See, I always do that. Try to put a C there. Inflection. I think I just spelled inflection wrong, didn't I? Anyway, inflection is also at 0, 0. So that's my x, y-intercept, my x-intercept, my y-intercept, and my point of inflection. Okay? And we know that it is down from -infinity to 0, and it is up from 0 to +infinity. All right, what does this all look like on the graph? Well, x-intercept and y-intercept and point of inflection all go there. After that point, from 0 to positive infinity, it is concave up. And before that point, from negative infinity to 0, it is concave down. The other thing you can do is there's a lot of these graphs that you already recognize. You recognize that this should be a cubic function. You recognize that this should be a cubic function. So this one might not. We know that whenever we have a rational function, it's going to have parts to it. So you know, if you're looking at something squared, you know that you're going to be looking at a parabola. Okay? If you're looking at something cubed, you know you're going to be looking at something that goes up and then down, or at least has that point of inflection in the middle, has a concave down and a concave up section. And if you're looking at something to the 4th power, a lot of times that's going to end up looking like a W. It's going to have like 2 maximums and 1 minimum, or 2 minimums and 1 maximum. So we got to keep that all in mind when we're trying to picture these graphs. Okay, so the next thing we're going to do is we're going to actually work on these 3. You can pause it here. I'm going to use the next video to actually show the work, but you can work on those 3 and trying to get the first derivative and its information, the second derivative and its information, and see if you can get some points on that graph.